Hello students, welcome to physics class. In today's class we are going to discuss about the position of the images through the different lenses. See how we studied for the mirrors. In the same manner we are going to study in the lens part also. In previous class we talked about the lens, what is the lens, how to what are the different types of lenses, and we discussed some terminology like what is the principal axis, what is the optical center, and what are the paraxial rays. These are all we discussed, and how to draw the normal. That all part also we discussed. What is center of curvature? Totally two center of curvatures are there for one lens. ಪ್ರತಿಯೊಂದು ಲೆನ್ಸಿಗೆ ಎರಡು center of curvature ಇರ್ತದೆ. But in case of mirrors, it is only one center of curvature. Like this, whatever things we require, basic things that we already studied in a previous class. Thus today we are going to study about the image formation, and step by step. Totally we are going to study about the 5 types of image formation through the convex lens. 5 different positions we will get the image. In a 5 different positions we will get the image. One by one we are going to study in this class. This is the main motto of this class. Okay, just don't forget the previous classes. Whatever we studied in the previous class, just you keep it in your memory, and then only you will get the more idea and more clear picture about the new concept of this class. If you studied very well, then only you can understand the next classes. That's why whatever you studied in a previous class, watch the video properly and make the notes. Just go through that notes, then you come to the next, you watch the next video, then only will you get the more clear idea. Otherwise what happens, if you not watch properly the previous video, then you can't get the clear idea about the new class, then you will lose the interest. That's why now what I'm going to tell us is, each and every video is very important. That's why go through all the videos, don't neglect it, don't skip any videos, continuously it is. Okay, now we will start the position. Positions of image. Positions of image. This positions of image or image formation in the lens is directly not come into the board examination. Board examination ಒಳಗೆ ಇದ್ರ ಮ್ಯಾಗ ಕ್ವಶನ್ಸ್ ಬರ್ತಾವ ಅಂತ ನಾ ಹೇಳಂಗಿಲ್ಲ. ಬರ್ಬೋದು, ಭಾಳ ಜಾಸ್ತಿ ಅಂದರೆ 1 ಮಾರ್ಕ್ಸ್ ಕ್ವಶನ್ ಬರ್ಬೋದು ಅಷ್ಟೇ, ಜಾಸ್ತಿ ಮಾರ್ಕ್ಸ್ ಬರಲಿಕ್ಕಿಲ್ಲ. ಬಟ್ this is very important, because next to understand next one more derivation, lens makers formula is there, and some other concepts if you want to understand, then it is compulsory. Not only this one, even though it directly the question may not appear in your examination, board examination, but the questions related to this image formation concept is appear in your competitive examination, NEET or CET question paper. If you go through any CET question paper or NEET question paper, questions related to this image formation is compulsorily. That's why this part is not important for your as per board examination, but concept, to understand the concept wise, it is very important. To understand, to face the competitive examination, this part is very important. So don't neglect. And first case for convex lens, first I consider convex lens, then I will go to the concave lens. This is a convex lens. This is a convex lens. This is the principal axis. This is the principal axis. Here, what I consider, this is the principal axis. and here 2f distance, it is a f distance. F distance. Similarly, this is a 2f distance. Here f distance. See, what first I consider convex lens. I draw the one principal axis and I consider 2 points here, f, because each and every lens has a 2 focal lengths. One is related to one curved surface, one focal principal focus is related to the one more surface. Therefore, I draw so I noted some points here. 2f point means double the points. Here this is O point. O is the optical center. What is optical center? Optical center is already I explained. If the light is incident on the lens, it passes through the lens and it emerges out. If the emergent beam and incident beam both are parallel, then where this refracted beam cuts the principal axis, that point is optical center. Through that point, through the optical center, if the light incidents, it will move without a deviation. There is no refraction. ಯಾವಾಗ ಆಪ್ಟಿಕಲ್ ಸೆಂಟರ್ ಥ್ರೂ ಪಾಸ್ ಆಗ್ತದೆ ಲೈಟ್, ಆವಾಗ ಯಾವುದೇ ರೀತಿ ರಿಫ್ರಾಕ್ಷನ್ ಆಗೋದಿಲ್ಲ. ದೇರ್ ಇಸ್ ನೋ ಬೆಂಡಿಂಗ್ ಆಫ್ ದ ಲೈಟ್, deviation, there is no deviation. Directly it will pass. This is the diagram what I can say. If the body or object or body, okay, object, first case what I consider, object is beyond 2f. First case it is, in first case what I consider, if the object is beyond 2f means like this. Beyond 2f ಕಿಂತ ಈ ಕಡೆ, similarly as we studied in mirrors, the same manner we are going to study here also. If the parallel beam incidents, it bends and after refraction it passes through the principal focus. This is the first condition. And how we studied in the mirror case, the same manner. If the principal, if I consider lens like this, see, this is the principal axis. If the incident ray is parallel to the principal axis ಗೆ ಪ್ಯಾರಲಲ್ ಆಗಿ ಲೈಟ್ ಇನ್ಸಿಡೆಂಟ್ ಆಯ್ತು ಅಂದರೆ, ಆಫ್ಟರ್ ರಿಫ್ರಾಕ್ಷನ್, ಆಫ್ಟರ್ ಕಮಿಂಗ್ ಔಟ್ ಫ್ರಮ್ ದ ಲೆನ್ಸ್, ಇಟ್ ಕಟ್ಸ್ ದ ಪಾಯಿಂಟ್ ಎಫ್, one case. And if the light which is passing through the principal optical center, if it is a lens, remember, if it is a lens, if it pass through the optical center, it will pass without any deviation. This is also one condition. First condition. Second condition, if these are the two important conditions. And if I consider the one more type condition, what is that? When the light is incident like this, it makes some angle with the horizontal or principal axis ಗೆ ಸ್ವಲ್ಪ angle ಮಾಡಿ ಇನ್ಸಿಡೆಂಟ್ ಆತಂದ್ರೆ, it gets refracts and it cuts the surface here and again it emerges out. Light will move like this. These are some conditions we should understand. When the principal axis ಗೆ parallel ಆಗಿ ಹೋಯ್ತು ಅಂದ್ರೆ ಎಮರ್ಜೆಂಟ್ ರೇ ಏನಾಗ್ತೈತಿ, ಎಫ್ ಪಾಸ್ ಆಗ್ತೈತಿ. ಆಪ್ಟಿಕಲ್ ಸೆಂಟರ್ನಾಗ ಪಾಸ್ ಆದ್ರೆ ಇವೆರಡು ಅಂದ್ರೆ ಭಾಳ ಇಂಪಾರ್ಟೆಂಟ್. ಫಾರ್ ಎವ್ರಿ ಇಮೇಜ್ ಫಾರ್ಮೇಷನ್ ಸ್ಟಡಿ ಮಾಡಬೇಕಾದ್ರೆ ಇವೆರಡು ಕಂಡೀಷನ್ ತೊಗೋತೀವಿ ಚೆಕ್ ಮಾಡೋಕ್ಕೆ. ಯಾವುದ್ರು ಒಂದು ಪ್ಯಾರಲಲ್ ಬೀಮ್ ಇನ್ಸಿಡೆಂಟ್ ಮಾಡಿ ನೋಡೋದು, ಇನ್ನೊಂದು ಆಪ್ಟಿಕಲ್ ಸೆಂಟರ್ ಥ್ರೂ ಪಾಸ್ ಮಾಡೋದು. ಆಪ್ಟಿಕಲ್ ಸೆಂಟರ್ ಮತ್ತು ಇದಕ್ಕೆ ಎರಡಕ್ಕೂ ಪಾಸ್ ಮಾಡಿ ನೋಡ್ಬಿಡೋದು. ಆಟೋಮೆಟಿಕ್ಲಿ ನಮಗೆ ಸಿಗ್ತೈತೆ. ನೀವು ಎರಡು ಕಂಡೀಷನ್ಸ್ ಚೆಕ್ ಮಾಡಲಿಕ್ಕೆ ಬೇಕು. ಫಸ್ಟ್ ಕಂಡೀಷನ್ ಏನು ರೀ, ಯಾವಾಗಲೂ ಒಂದು ಲೆನ್ಸ್ ಮೇಲೆ ಪ್ಯಾರಲಲ್ ಬೀಮ್ ಇನ್ಸಿಡೆಂಟ್ ಆತಂದ್ರೆ ಅದು ಹೊರಗೆ ಬಂದಂಥ ಲೈಟ್ ಅಲ್ಲಿ ಪಾಸ್ ಎಲ್ಲಿ ಕಟ್ ಆಗ್ತೈತಿ, ಎಫ್ ಲೋ ಕಟ್ ಆಗ್ತೈತಿ. ಅದೇ ರೀತಿ ಆಪ್ಟಿಕಲ್ ಸೆಂಟರ್ನಾಗ ಪಾಸ್ ಆದ್ರೆ ವಿತೌಟ್ ಎನಿ ಡಿವಿಯೇಷನ್ ಇಟ್ ವಿಲ್ ಮೂವ್. ಇವೆರಡು ಅಂತ ಭಾಳ ಇಂಪಾರ್ಟೆಂಟ್. ಈಗ ಮಿರರ್ ಒಳಗೂ ಇದೇ ಟೈಪ್ ಐತೆ ನಿಮಗೆ, ಮಿರರ್ ಒಳಗೆ ಕೂಡ ಹಿಂಗೆ ಇದೇ ಟೈಪ್ ಕಲ್ತೀವಿ. ದ ಸೇಮ್ ಮ್ಯಾನರ್ ಹಿಯರ್ ಆಲ್ಸೋ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಸ್ಟಡಿ. ಏನು ಗೊತ್ತಿರಬೇಕು ನಮಗೆ ಇಮೇಜ್ ಫಾರ್ಮ್ ಮಾಡಬೇಕಾದ್ರೆ ಲೈಟ್ ಯಾವ ಡೈರೆಕ್ಷನಾಗ ಇನ್ಸಿಡೆಂಟ್ ಆದ್ರೆ ಏನಾಗ್ತೈತಿ, ಹೌದಾ? ಇಫ್ ದ ಲೈಟ್ ಇನ್ಸಿಡೆಂಟ್ಸ್ ಪ್ಯಾರಲಲ್ ಟು ದ ಪ್ರಿನ್ಸಿಪಲ್ ಆ್ಯಕ್ಸಸ್ ಇಟ್ ವಿಲ್ ಕಟ್ಸ್ ದ ಪ್ರಿನ್ಸಿಪಲ್ ಫೋಕಸ್. ಲೈಟ್ ಹಿಂಗೆ ಬಿದ್ದು ಬೆಂಡಾಗಿ ಪ್ರಿನ್ಸಿಪಲ್ ಫೋಕಸ್ನಾಗ ಕಟ್ ಆಗ್ತೈತಿ. ದಿಸ್ ಇಸ್ ದ ಒನ್ ಕೇಸ್. ಇಫ್ ದ ಲೈಟ್ ಪಾಸ್ ಟು ದ ಆಪ್ಟಿಕಲ್ ಸೆಂಟರ್ ಇಟ್ ವಿಲ್ ಪಾಸ್ ವಿತೌಟ್ ಎನಿ ಡಿವಿಯೇಷನ್. ಅದು ಲೈಟ್ ಆಪ್ಟಿಕಲ್ ಸೆಂಟರ್ನೇ ಪಾಸ್ ಆದ್ರೆ ಯಾವುದೇ ಡಿವಿಯೇಷನ್ ಇಲ್ದೂ ಪಾಸ್ ಆಗಿ ಹೋಗ್ತದೆ. ಇಷ್ಟನ್ನು ತಲೆ ಇಟ್ಕೊಳ್ರಿ. ಇಷ್ಟು ಯು ಶುಡ್ ದಿಸ್ ಮಚ್ ಆಫ್ ಇನ್ಫಾರ್ಮೇಷನ್ ವಿ ಶುಡ್ ನೋ ಟು ಫಾರ್ಮ್ ದ ಇಮೇಜ್. What I consider, if the object I kept beyond 2f, first case, I consider a convex lens, I draw the principal axis, I denoted the f and 2f. ಯಾಕೆ ನೀವು ಸೆಂಟರ್ ಆಫ್ ಕರ್ವೇಚರ್ ತೊಗೊಂಡಿಲ್ಲ? ತೊಗೊಳ್ಬೋದು, ಅದನ್ನು ಕೂಡ ಮಾಡ್ಬೋದು, ಬಟ್ ಮಾಡಿಲ್ಲ ಅಷ್ಟನ್ನು, ಮಾಡ್ಬೋದು, ಏನು ಸಮಸ್ಯೆ ಇಲ್ಲ. ನೋಡಿರಿ, when the light is incident parallel to the principal axis it cuts the point at f ಒಳಗೆ ಕಟ್ ಆಗ್ತೈತೆ ರೀ. ಅದೇ ರೀತಿ ನೋಡಿರಿ, if the light incident through the optical center it will pass without a deviation. ಯಾವುದೇ ಡಿವಿಯೇಷನ್ ಇಲ್ಲ, ಪಾಸ್ ಆಗಿಬಿಡ್ತದೆ. ಇವೆರಡು ಎಲ್ಲಿ ಮೀಟ್ ಆಗ್ತವೆ ರೀ? ಎರಡು ಲೈನ್ in between the 2f and f. You will get the image. Remember, I got the image here in between 2f and f. Image ಯಾವ ಥರ ಐತೆ ನೋಡ್ರಿ, image position ಎಲ್ಲಿದ್ರಿ? image is in between f and 2f. f and 2f ನೋಡ್ಬೇಕೈತ್ರಿ. inverted real image. Always inverted images are real images. ನಿಮಗೆ ಮೊದಲು ಹೇಳಿನ ಹೌದು. ದ್ಯಾಟ್ಸ್ ವೈ ದ ಇನ್ವರ್ಟೆಡ್ ಇಮೇಜಸ್ ಆರ್ ಆಲ್ವೇಸ್ ರಿಯಲ್. ಇದು ಕೂಡ ತಲೆ ಕೆಳಗೆ ಇಮೇಜ್ ಬರ್ತದೆ, ಇನ್ವರ್ಟೆಡ್ ಐತಿ. ಆಬ್ಜೆಕ್ಟ್ ಈಸ್ ಲೈಕ್ ದಿಸ್ ಬಟ್ ಯು ಗಾಟ್ ದ ಇಮೇಜ್ ಇನ್ ದ ಇನ್ವರ್ಸ್ ಡೈರೆಕ್ಷನ್. ದೇರ್ ಫಾರ್ ಇನ್ವರ್ಟೆಡ್ ಇಮೇಜ್ ಈಸ್ real image, inverted and real image it is. And what is the size of this one? Comparatively object size and this image size, if you compare, it will diminished, small it is, diminished. First case, object beyond the 2f, object if I kept the beyond the 2f, then you will get the image in between the f and 2f. First case, remember, in between the f and 2f. Then image is between f and 2f, and inverted and real image, diminished image, small size. Diminished image size is small and real image. This is the first case. Second case, if the object at 2f, ನೀವು ಮಿರರ್ ಯಾವ ಥರ ಮಾಡಿದ್ರಲ್ಲ, ಬಿಯಾಂಡ್ ದ ಸಿ, ಆಟ್ ಸಿ ಆ್ಯಂಡ್ ಇನ್ ಬಿಟ್ವೀನ್ ಸಿ ಆ್ಯಂಡ್ ಎಫ್, ಈ ಥರ ಮಾಡಿದ್ರಲ್ಲ, ಇನ್ ದ ಸೇಮ್ ಮ್ಯಾನರ್ ಹಿಯರ್, beyond the 2f, at 2f, next at 2f, object if I kept at 2f. If I consider lens here, this is the principal axis, again principal axis same. Here 2f if I consider, f, we'll see. If object is at 2f, if I kept the object is at 2f, ಏನು ಮಾಡ್ಬೇಕ್ರಿ, one line from the top of the object ಇಂದ ಒಂದು ಲೈನ್ ಡ್ರಾ ಮಾಡಿರಿ. ದಟ್ ಈಸ್ ಅ ಪ್ಯಾರಲಲ್ ಟು ದ ಪ್ರಿನ್ಸಿಪಲ್ ಆಕ್ಸಸ್ ಪ್ಯಾರಲಲ್ ಮಾಡ್ತೀರಿ. ಇಫ್ ದ ಲೈಟ್ ಈಸ್ ಇನ್ಸಿಡೆಂಟ್ ಪ್ಯಾರಲಲ್ ಟು ದ ಪ್ರಿನ್ಸಿಪಲ್, ಫೇರ್ ಇಟ್ ವಿಲ್ ಮೀಟ್ ಅಟ್ ಎಫ್ ಒಳಗೆ ಮೀಟ್ ಆಗ್ಬೇಕಾದ. This is the f point or meet ಆಗಬೇಕಾ? Yes, fine. Then one more line you should remember, one more line, which is one more light incident through the optical center. It will transmit without a deviation, without a deviation it will transmit. See here 2f is there, the object is like this. This is second case. Object image hengaitre idrolaga, image is inverted, image is inverted, real image, inverted and real image, inverted and real image, and at 2f image is at 2f, at 2f. ಇಲ್ಲಿ ನೋಡಿ ಹೆಂಗೆ ಬರ್ತದೆ, ಇಮೇಜ್ ಈಸ್ ಇನ್ ಬಿಟ್ವೀನ್ ಎಫ್ ಆ್ಯಂಡ್ 2f. ಹಿಯರ್ ಇಮೇಜ್ ಈಸ್ ಅಟ್ 2f ಎಕ್ಸಾಕ್ಟ್ಲಿ. ಇಲ್ಲಿ 2f ಒಳಗೆ ಆಬ್ಜೆಕ್ಟ್ ಇಟ್ಟರೆ ಈ ಕಡೆ ಕೂಡ 2f ಒಳಗೆ ನಮಗೆ ಇಮೇಜ್ ಸಿಗ್ತೈತೆ. ಜಸ್ಟ್ ಲೈಕ್ ಅ ಮಿರರ್. ಅಗೇನ್ ಕಂಪೇರ್ ವಿತ್ ದ ಮಿರರ್ಸ್. ಮಿರರ್ ಒಳಗೆ ಸಿ ಒಳಗೆ ಆಬ್ಜೆಕ್ಟ್ ಇಟ್ಟರೆ ಅಟ್ ಸೆಂಟರ್ ಆಫ್ ಕರ್ವೇಚರ್ ಒಳಗೆ ನೀವು ಆಬ್ಜೆಕ್ಟ್ ಇಟ್ಟಿದ್ರಂದ್ರೆ ನಮಗೆ ಇಮೇಜ್ ಏನು ಸಿಗ್ತೈತೆ, ಅಲ್ಲಿ ಸಿಗ್ತೈತೆ. ದ ಸಿಮಿಲರ್ ಮ್ಯಾನರ್ if you kept the object at 2f, then image also at 2f. Therefore inverted and real image. What about size? If you see the object size and the image size, almost same, it is same size. Almost same size. Next, one more case to consider, that is the third case. Object is now beyond the 2f I kept. Next, in this case at 2f I kept. Next, if I kept the object in between f and 2f, is between f and 2f, f and 2f. Object is f and 2f. Again, consider convex lens. This is the principal axis. Remember, it is the principal axis. To f and f here. If I kept the object like this here, object ಇಲ್ಲಿ ಇಡ್ತೀನಿ ನಾ, in between 2f and f, in between 2f and f, light incident like this. Again, I consider parallaxial ray or parallel to the principal axis. It bends and it cuts the principal focus. Cut ಮಾಡ್ತೈತ್ರಿ. Okay. Where you will get the image. Listen. See here, if I kept the object between the f and 2f, then after passing through the lens, we will get the object beyond the 2f. See, if you compare these three equations, initially I kept the object beyond the 2f, image is in between the 2f and f. Next, I kept the object, I moved the object at a position of the 2f, then image also shifted at 2f. Once again I shifted the object in between f and 2f, the image also shifted. Again image, how it is, image is beyond 2f. 2f ಗಿಂತ ಆ ಕಡೆ ಬಂತ್ರಿ. real and inverted image, real and inverted image. Again here also, what about the size? Magnify it is, because if you compare the size of the object and image is bigger than object. Magnified. See how beautiful. ನೀವು ಯಾವ ಥರ ಈ ಕಡೆ ರೈಟ್ ಸೈಡಿಗೆ ನೀವು ಆಬ್ಜೆಕ್ಟ್ ಮೂವ್ ಮಾಡ್ತಾ ಹೋಗ್ತೀರಿ, ಆ ಇಮೇಜ್ ಕೂಡ ಮೂವ್ ಆಗ್ತಾ ಹೋಗೈತಿ. ತಿಳಿತಾ? ನೆಕ್ಸ್ಟ್ ಒನ್ ಮೋರ್ ಕೇಸ್ ವಿ ಹ್ಯಾವ್ ಟು ಕನ್ಸಿಡರ್, ದಟ್ ಈಸ್ ಇಲ್ಲಿ ಎಲ್ಲಿ ಆಬ್ಜೆಕ್ಟ್ನ ಇಲ್ಲಿ ಇಟ್ಟಿನಿ ಎಫ್ ಆ್ಯಂಡ್ 2f. ನೆಕ್ಸ್ಟ್ ಇಫ್ ಐ ಟೇಕ್ ಅಪ್ ದ ಆಬ್ಜೆಕ್ಟ್ ಅಟ್ ಎಕ್ಸಾಕ್ಟ್ಲಿ ಅಟ್ ಎಫ್ ಒಳಗೆ ಇಟ್ಟರೆ ಏನಾಗ್ತೈತಿ? ಇಫ್ ಐ ಕೆಪ್ ದ ಆಬ್ಜೆಕ್ಟ್ ಅಟ್ ಎಫ್, that we will discuss. Shall I remove this one once again? No, next case, sir. Fourth case it is. Yes. Object is at f. Object is at f. Object nelli ನೋಡಿ. ಚಂದ ಇಲ್ಲ, ಸಾರಿ. ಓಕೆ ಇರಲಿ. if I consider a principal axis like this, remember here I kept the 2f in between, exactly at this point, almost at this point. f ಇದು 2f ಐತಿಲ್ಲ, 2f ಐತಿ. ನಮಗೆ ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್ ಆಬ್ಜೆಕ್ಟ್ ಎಲ್ಲಿ ಇಡಬೇಕು? ಇಲ್ಲಿ 2f ಇತ್ತು, ನೆಕ್ಸ್ಟ್ ಇಲ್ಲಿ ಕೇಸ್ನಾಗ 2f ಆ್ಯಂಡ್ ಎಫ್ ನೋಡ್ಬೇಕು. ಈಗ ನಾವು ಅಟ್ ಎಫ್. ಇಫ್ ಐ ಕೆಪ್ ದ ಆಬ್ಜೆಕ್ಟ್ ಅಟ್ ಎಫ್ ಒಳಗಿಟ್ಟಿವಿ, ಇರಲಿ ನೋಡ್ರಿ. ಈಗ light incident parallel to the principal axis, it cuts the principal focus f, it cuts the principal focus, remember. Next, if I pass the light like through the sorry, if I pass the light through the optical center O, then it will move without deviation, and when the light is parallel to the principal axis, it will cut that f. 2f is here. If you extend these two lines, these two lines never get intersect, these two rays never get intersect, therefore this side there is no image formation. Or if you extend in the back side also, try to extend these backside also, there is no chance to get intersect, backside also no chance to get intersect, therefore only the image is formed, image is at infinity, finish. ಇಮೇಜ್ ಈ ಕಡೆ ಹೋದರೂ ಎಲ್ಲೂ ಕೂಡಂಗಿಲ್ಲ, ಈ ಕಡೆ ಎಕ್ಸ್ಟೆಂಡ್ ಮಾಡಿದ್ರು ಕೂಡ ಎಲ್ಲೂ ಮಿಕ್ಸ್ ಆಗಂಗಿಲ್ಲ. ನೋಡಿ, ದಿಸ್ ಇಸ್ ಲೆನ್ಸ್. ನಾವು ಎರಡು ಕಡೆ ನಾನು ಎಫ್ ಆ್ಯಂಡ್ 2f ಮಾರ್ಕ್ ಮಾಡೀನಿ. ಎಟ್ ಎಫ್ ಒಳಗೆ ಆಬ್ಜೆಕ್ಟ್ ಇಟ್ಟಿವಿ ಅಂದ್ರೆ ಈ ಥರ ಇಮೇಜ್ ಫಾರ್ಮ್ ಆಗ್ತೈತಿ. ಎಲ್ಲಿ ಇಮೇಜ್ ಫಾರ್ಮ್ ಆಗ್ತೈತಿ? ಇವೆರಡು ಲೈನ್ ಎಲ್ಲ ಒಂದು ಕಡೆ ಮೀಟ್ ಆಗಬೇಕಲ್ಲ, ಇಲ್ಲೆಲ್ಲ ಮೀಟ್ ಆಗಿ ಹಂಗೆ they never meet or they never intersect, therefore they intersect at infinity because these are parallel rays. If they parallel rays, if I consider, they meet at infinity. Infinity ಒಳಗೆ ಇಮೇಜ್ ಫಾರ್ಮ್ ಆಗಿಬಿಡುತ್ತೆ. ಇನ್ಫಿನಿಟಿ ಒಳಗೆ ಇಮೇಜ್ ಫಾರ್ಮ್ ಆದ್ರೆ ಅದು ಏನೈತಿ ಗೊತ್ತಾಗೋದಿಲ್ಲ. we not bother about that infinity. ಭಾಳ ದೂರದಾಗ ಎಲ್ಲೋ ಇಮೇಜ್ ಫಾರ್ಮ್ ಆಗ್ತದೆ ಇನ್ಫಿನಿಟಿ ಒಳಗೆ ಅಂದ್ರೆ ಇಟ್ ಈಸ್ ನಾಟ್ ಕನ್ಸಿಡರೇಬಲ್. ಅದು ಮಾಡೋ ಅವಶ್ಯಕತೆ ಗೊತ್ತಾಗಂಗಿಲ್ಲ ನಮಗೆ ಎಲ್ಲಿ ಇಮೇಜ್ ಫಾರ್ಮ್ ಆಗ್ತದೆ ಅಂಥೇಳಿ. ಅದನ್ನ ಎಕ್ಸ್ಟೆಂಡ್ ಬ್ಯಾಕ್ ಸೈಡ್ ಮಾಡಿದ್ರು ಕೂಡ ಎಲ್ಲೂ ಮ್ಯಾಚ್ ಆಗೋದಿಲ್ಲ, ಅದು ಎರಡು ಮೀಟ್ ಆಗೋದೇ ಇಲ್ಲ, ಎರಡು ಕೂಡ ಅಲ್ಲೂ ಕೂಡ ಪ್ಯಾರಲಲ್ ಬೀಮ್ ಇರೋದ್ರಿಂದ ಬ್ಯಾಕ್ ಸೈಡು ಹೋಗಂಗಿಲ್ಲ, ಈ ಕಡೆ ಹೋಗಂಗಿಲ್ಲ ಅಂದಾಗ ಎಲ್ಲಿಯೂ ಕೂಡ ಇಮೇಜ್ ಫಾರ್ಮ್ ಆಗೋದಿಲ್ಲ. at f if I kept the object at f, there is no image formation, means it is a image will form at infinity ಒಳಗೆ image form ಆಗ್ತೈತಿ. okay, at infinity we will get the image. Next we are going to do one more thing, that is a, remember, object if I kept the f and o, in between f and o, fifth case, object is in between f and o and f ಅನ್ನಬೇಕು ಒಂದು ಕಡೆ ಆಬ್ಜೆಕ್ಟ್ ಇಡ್ತೀವಿ ನೋಡ್ರಿ. ಎಫ್ ಇಲ್ಲದ 2f ಇಲ್ಲೈತಿ, ಆಬ್ಜೆಕ್ಟ್ ನೇಲಿ ಇಡ್ಬೇಕಣ್ಣ ಓ ಇಲ್ಲೈತಿ, ಹೌದಾ? ಇದು ಲೆನ್ಸ್ ಆ್ಯಸ್ ಇಟ್ ಈಸ್. ಇದು ಡಯಾಗ್ರಾಮ್ನ ಸ್ವಲ್ಪ ಚೇಂಜ್ ಮಾಡೋಕ್ಕೆ ಕಷ್ಟನ ನೋಡ್ರಿ. ಆಬ್ಜೆಕ್ಟ್ನಲ್ಲಿ ಇಡ್ಬೇಕು, ನಾನು ಎಫ್ ಆ್ಯಂಡ್ ಓ ಇಡ್ಬೇಕು, ಇಲ್ಲಿ ಇಡ್ಬೇಕು, ಇಟ್ಬಿಟ್ರಿ ಆಬ್ಜೆಕ್ಟ್ನ ಇಟ್ಬಿಟ್ಟಿವಿ. ಓಕೆ, it cuts the principal axis like this. Then if the light is passed through the optical center, the light which is passing through the optical center, it does not deviate from its path. If it does not deviates, then if it does not deviate means these two rays, they are never going to meet. Watch observably, watch carefully. See, one light ray is incident parallelly, and after refraction it passes through the principal focus through the f. Okay, one more line or ray which is passing through the optical center, it is deviates, without deviation it passes. If you, these two lines, if you see, these are moving in an opposite direction, therefore they never intersect each other. If you extend these two rays, they never intersect each other. If you extend backside, see, somewhere here they will meet, somewhere here they will meet. If I extend in backside, reverse direction, the object image will form at this position, means they will meet at this position, therefore the image will form at this, image will form. Therefore image, how image is okay, image is real or virtual, it is a erect image, virtual erect image, virtual erect image. Virtual it is because it is same side of object ಯಾವ ಸೈಡ್ ಇದೆಯಲ್ಲ ಅದರ್ ಸೈಡಿಗೆ ಬಂದೈತೆ ನಮಗೆ ಇಮೇಜ್ ಅಂದರೆ ಏನ್ರಿ, ಇಟ್ ಈಸ್ ಅ ವರ್ಚುವಲ್ ಇಮೇಜ್ ಆ್ಯಂಡ್ ಇಟ್ ಈಸ್ ಅ ಎರೆಕ್ಟ್. ಆಲ್ವೇಸ್ ಎರೆಕ್ಟ್ ಇಮೇಜಸ್ ಆರ್ virtual image and its erect image. Image is virtual and erect and magnified. Size is magnified. These are the 5 positions we consider to get the image. These 5 positions, this image formation concept is very important for your competitive examination as well as your laboratory work. Even in lab, if you want to get the image, we use this compulsorily. We use this concept compulsorily. In laboratory work also it is important, your competitive examination also important, and to understand the concept also very important. See, totally we consider 5 cases: beyond the 2f, at 2f, and if the object is in between the f and 2f, and at f, and in between the o and f. These 5 cases we considered. Okay, only we will get the virtual image in case of F and O case. In when the object is kept between the O and F, then only we will get the virtual erect image. That is the only case. In remaining all the cases, real image only. But when the object is at F, there is no image, or image will form at infinity. Image ಇಲ್ಲ ಅದರ ಅರ್ಥ ಅಂದರೆ ಇಮೇಜ್ ಫಾರ್ಮ್ ಆಗೋದು ಇನ್ಫಿನಿಟಿ. ಈ ಥರ 1 ಮಾರ್ಕ್ಸ್ ಕ್ವಶನ್ಸ್ ಎಲ್ಲಿ ಕೇಳ್ತಾರೆ, when we get the object, when we get the real and when we get the virtual and erect object, erect image in a convex lens. Example question ಹೆಂಗೆ ಕೇಳ್ಬೋದು, at what position of the object the image is virtual and erect. ಯಾವ ಪೊಸಿಷನ್ ಒಳಗೆ ಆಬ್ಜೆಕ್ಟ್ ಇಟ್ಟಾಗ ನಿಮಗೆ ವರ್ಚುವಲ್ ಇರಬೇಕು, ಎರೆಕ್ಟ್ ಇರಬೇಕು, ಆ ಥರ ನಮಗೆ ಸಿಗಬೇಕು ಏನು ಇಮೇಜ್. ಅದು ಎಲ್ಲಿ ಸಿಗ್ತದೆ? ಓಕೆ, ಇಟ್ ಈಸ್ ಫೈಂಡ್ we can find the real and or virtual and erect image when an object is in between the O and F. Similarly, when the image is formed at infinity, when object is kept in at F. These are some points we should remember. Next, these are the important, not in directly they may not get the questions in a board examination, but you may get in the competitive examination as well as in laboratory. It is more helpful if you know. This much you will remember, and remaining part I will continue in a next class. If you have any doubts regarding this image formation, you can ask.